Okay, so members, today we are going to see how we use more of the geometric key progression to handle these questions. Now, here is that find the number of terms of a series. This is the series now such that its sum, the sum of a series is greater than 1000. But please don't forget to subscribe. Now, so the series they are giving us is this. So they want its sum, they want the number of terms so that its sum is greater than 1000. So they want n. They're asking us to get n. In order to get the sum, we first need to know is the ratio, the formula we are going to use. So from here is that our first term is 2, and our common ratio is that we get 4 over 2 is also a 2. So from here is that the formula we are going to use is that our r is now greater than 1. So the formula they are going to use is the sum is a into rn minus 1 over 1 minus r. So this is the formula, r minus 1. This is the formula that we are going to use. So they want this sum to be greater than 1000. So now, meaning that if my Sn is greater than 1000, I have to substitute from here my n into rn minus 1 over r minus 1 should be greater than 1000. Can you substitute now? From here my a is that my a is 2 into my r is 2 power n I want over 2 minus 1 greater than 1000. So this is 1, so when I divide this by 2, I'll be adding now from here, it's not my 2n. I'll be having this to divide this, I'll be having 500. Then 500, I take this the side, I'll be having 501. So from here, I start members, all you do is just press natural log both sides. So if I introduce natural log, I'll be having n natural log of 2 greater than natural log of 501. So from here, I start my n greater than, now I divide this both sides. They are now natural log of 501 over natural log of 2. And there you get your calculator and you press that natural log 51 divided by. So the answer I get here is n, my n is greater than 8.9686 for the small person. Now, the interpretation comes in here. So the number of terms you want are greater than 8. So if you come on your number line, you see if you have here 7, and you have here 8, and you have here 9. So the number of terms are always all numbers. So the number of terms greater than 8.9 is that if I want something greater than 8.9, it's going to be 9. So therefore, those number of terms should be 9. And that is our answer. So when you get number of terms of this DP as 9, their sum is going to be greater than 1000. Now, what if this one was n less 8.96? Now, the interpretation here matters. If you want something, you start our 8.96 is somewhere here. If you want something less than this, start our next integer before this is 8. So here our n will be 8. But if you want the number, the next integer above this is 9. So that's the difference. If it was less, it will be 8. But if it's greater, the next integer after this is 9. But the next integer below this, the integer below this is 8. So if it was less, that would be the way around. But because it's greater, this is all they wanted. Okay. So now, we also have this number. A man deposited shillings that at the beginning of every year. The moment you hear the word every year, each year, those ones and numbers we had using series, specifically DP, at a rate of this. Now, so this man, the rate this man is using is 2%, which is 0.02. That's the rate. If you started depositing in 2018, find this balance at the end of 2022. Now, from here, You know that our amount, how we get our amount in the nth year, is always given by the principal times 1 plus r power n. Meaning that in my first year, this man will be having the principal 1 plus this power 1. In the second year, this man will be having. In the third year, up till when this man reaches the nth year, where this man will be having p plus r power n. But we want the total amount. The total amount, after all these years, we add the amount in the first year, amount in the second year, amount in the third year, until when we reach the amount in the nth year. So our total amount total will be amount in year 1, amount in year 2, amount in year 3, plus when we reach the amount in the last year, the nth year. So from here, we start, what is our n? First of all, here we have 18, 1 equaling our amount in the first year is, then this one, by the way, okay, this one is our rate. Let us call this our rate. Okay, this is our rate. It's okay. Our rate, then power 2, then plus p into, then plus up to when we reach p power n. Now, from here I start, we want to know, is it a GP? We want to get our common ratio. So let me call my common ratio capital R. So let me call this small r the rate, and I call this capital R the common ratio. We said we get this divided by this, p into 1 plus r power 2 plus r. So that this one cancel this and cancel this. So 1 plus r is our common ratio. But from here, our r is 0.2, so it would be 1 plus 0.02. That this is 1.02. So that our common ratio is 0.2 and square than 1. So the sum we are going to use is, the sum here we are going to use is n into r power n minus 1 over 1 r minus 1. Why are we using this? Because that our r is greater than 1. Now, here I want to get n. What is n? Now n we say you count from 2018, 2012, I mean 2022, 2018, 19, 20, 21, 22. So here I start, our n is 5 years. Or alternatively, you can get n by saying 2022 minus 2018. Then if you do this like this, you don't forget always add 1. So still we have n will be 5. So now if we substitute now, the common mistake people do, this a is always the first term. So our first term here is this. So here, my sum after 5 years will be, my first term is this one, which is p into 1 plus r. Then into my r, n minus 1 over r minus 1. So this a is always the first term from here. So my a, the first term is always p into 1 plus r, the first term here, because it's a dp. Now we substitute our principal is here 100,000, then we have the r, we have everything. So our s5 now will be the principal, which is 100, into 1 plus r, 1 plus r, which is 1.02. Now in brackets, our r, now this one I'm going to use capital R so that we can really differentiate. Let me use capital R here, capital R here, so that we can differentiate the two, and you don't get confused. So R, this is why we are using this R. This R is just the rate, but capital R is the common ratio. So if I differentiate that with this, so this one is 1.02 power 5 minus 1 over 1.02 minus 1. And here now our sum after 5 years, you get your calculator, you say So the amount I'm having here to be 530.0963 shillings. So at the end of those 5 years, this man will be having that amount. So that's how we use this idea of series to handle these questions. But this one, what if this one is 8 at the beginning, each year, every year, then we use series like this. So please don't forget to subscribe. I wish you the best.